diploma.
So, whether any companies are recruiting this, actually those who are taking training from this?
Yes, yes, sir.
Are you facilitating that kind of facility?
We do not commit any placement commitment, sir. But yes, at our circle, we are a team of 15 and even professors are there. So we are all as a team, in our circle, if some opportunities are there for selected students, we are offering. Recently, a Chennai-based company, startup company called as CY4, there they had 5 vacancies, sir, for graduate engineer training. So for them, we have recommended 10 students, and almost they are at the final stage. So hope they get selected in that organization. That way we help, sir, for selected students.
Yeah, like training actually is basically industry oriented course. So how we are facilitating
like they are doing some live projects also. So they are showcasing that what they have learned, that skill they have applied for the some project. So with that, their performance will be assessed. So maybe that in that way their career also will prosper.
Normally in certification and also people will get certificate like they have gone through this course like that and all. But here we are providing what are the course content that we covered over here. Those things we are highlighting over here. That could be the helpful for the people who are recruiting for them actually. Not only this, in an advanced level courses also we are offering like how we are able to connect this PLC setup with our drives. Like how the digital twin model they can able to make it like that and all we are showcasing here. So that is the main thing. Even when some of the students also working on the same basis.
So whether the undergraduate course or the students are taking this is an elective course or a main course?
Academically separate.
It's purely on their own desire, sir. If they want to pursue this course in the sense, they can able to avail it, sir. It's like that, sir. It is not like their elective subject, not like that and all.
So
it's purely
linked with
Academic.
they can
Definitely relevant, sir. Relevant to academics. But module-based training, sir. There is a module-based training.
Can you please explain about the sensors you have here and there?
Sir. So actually, recently our students were done some of the projects, sir. One of the project that we were highlighted over is that automatic weight sorting station. Whereas 3 sensors they have placed over there. Those 3 sensors are just optical sensor. So the optical sensor which senses the objects and it will provide a command of just zeros or ones. And then we have kept one more load sensor into that. That load sensor will calculate the object weight and it will tell us whether I need to go by this direction or that direction, like a sorting related perspective they have created in such ways, sir, actually. That is one of the project that students recently did this place. And one more project here you can see there is a automatic car washing station is there. There also they have used a proximity sensor actually over there. Metal objects they are sensing over there. With that help it will be more like a continuous sequence model. Once the soap water will be poured on the top, then it will be flushed over with brushes and then it will be carried out with the new water, then dryer will be performed like that. The sequence they have made it in that programs actually. So like that students did some little bit of projects that were highlighted over there. Some of them we were dismantled and kept it aside actually. And another thing I have highlighted.
But it's a working model, and the ones which you are seeing right now is done by MSME students.
Those
MSME
are
Technological Center, YZ students with a minimum budget they have done these projects. But at the center we have a variety of sensors. We have inductive sensors, we have photoelectric sensors, we have color code sensors. We are also working with the instruments like level related, so level sensors, flow sensors, temperature sensors. This kind of sensors we are, pressure sensors we are working with. Some are industrial sensors, some are used for the project purpose, but all variety of sensors we are working with.
Smart factory you can see all
Yes. Yes, sir. RFID, yes, sir. We have radio frequency, those sensors also, which detects the entire process flow and gives us the data. Such sensors also we are using.
What are the required sensors you are providing all the sensors to the students?
Yes, sir. The ones which are there at the center. And the ones which are there at the sensor, they can use it, sir. They can dismantle from our system and they can start working with it. But those which are not there, then they will have to purchase it.
They have to.
As a part
As
of
a
the
part of
project.
internship, they want to do a
As group
project.
project,
They
sir.
have
3-4
to
people
purchase.
will be there. If that sensor is not available, then they will have to purchase.
So level sensor means what? Like for water level?
Yes, sir. Yes, sir. Level, water level or any fluid levels in the tanks in process industries, whichever overhead tanks are there or otherwise also whichever tanks are there those sensors are actually installed. So how to parameterize it manually, how to do it with the software. Now sometimes it will be installed in a confined space. So there we cannot go and do much of things. So how to connect it to the software, parameterize it to the software. Such techniques are taught to the students.
I mean, gas industries and all, most of the foams or some other gases will be on stagnant on the top. So that sensor need to be capable to take what is the exact level it is in the tank actually. That
Humidity based sensors also.
We have one, sir. We have one in the smart factory.
Like especially for the winter time, as we can also in national region.
Yes.
And so that actually like fog is coming to
Those humidity sensor is provided for the equipment at our center, because we have to maintain beyond some humidity level. Obviously, our equipment also will be damaged. So, as a part of that equipment, we got that sensor.
So what is the price of that? Like level sensor and
Maybe around 1 to 2.
normally, sir, if you want to make a prototype in the sense that will be little costly, sir. If it's an industry standard in the sense that will be more costly. In each and every lab, we are facilitated with some of the sensor for the students' perspective. How
for
this
the
sensor?
understanding.
Yes, for that perspective, we are
right.
The ones which you are seeing right now are the 400, 500 only, sir, which are done by the students. But our Siemens industrial sensors, let us say level or flow or something, that will go around 1 lakh each. It will have transmitter and it will have both the transmitter and also the receiver. Such sensors are costly.
You will
Branded
get the
sensors.
information also. Like with that sensor, we get the information.
Yes, sir. We will get the information. We can upload it into our software, modify it, then download it back to the sensor. Such facilities are available.
And again, like solar panels, right? Will actually come up from dust. So what level of the dust is like that? Also, you are looking for. And then so at what time is supposed to go for cleaning on the surface of the solar panel? As is actually really suitable for the panels.
So I think either faculty or students is designing something in the AutoCAD or something. Are you developing that product in this?
Yes, sir. That's the beauty of our center. To begin with modeling, as you said, starting from the idea, modeling can be done at our center, which means designing. The product designing can be done, validation and testing can be done at our center. Then followed with either we go with CNC and the original manufacturing. We can start with the manufacturing. So from the ideation to the actual product can be done at our center.
You are also giving certification.
Yes, sir.
Some
You are mentioning about the internship actually. Those four
Appreciation.
things will tell to the students
Yes, sir.
how to
Yes,
design a
that's
product.
true, sir.
Then how to validate this product, whether you are manufacturing either additive or subtractive, either CNC machine or additive
3D
manufacturing
printing.
machine. So with that help, how you are manufacturing this product without a defect for a user basis. Like that we are providing the training. Once they are qualified for that, then the concerned expert in each and every lab will tell us, then only we will provide the certification along with the course content what they have gone through over it.
I think some students have made some products, right?
Sir.
I think you have implemented any product in this industry.
Actually,
After the completion of training,
sir.
they design something like
Sir.
we developed or not those things?
So, sir, as a part of the internship, we have allotted them to troubleshoot few systems that we have done. We have not developed as such, but yes, the model, what you said, simple models from the design stage to the manufacturing, that we have done, either going with 3D printing or CNC. But sometimes we allot them the real-time issues and we ask them to rectify that as a part of their training. So they get us that system ready and they will submit it to us. That way also we do.
So, like as you said, that one of the students is getting new idea as per the information which you are being provided, and by adding that maybe some new product, maybe is looking for something maybe related to the social sector.
Okay.
So now the question is that whether the funding is provided by the center or maybe like who are in our
Okay, so if it is really good, then we approach Siemens also to sponsor that project. If it is that level, definitely we will be proud to take that opportunity and initiate it, definitely. But if it is a normal level project, yes, in our budget, whatever is possible, we do it for students. Coming back to certification, sir, yes, sir, definitely we provide the certification after completion if they qualify the course. And assessments will be there, practical tests will be there, written test will be there, they have to qualify. And for students who do best projects, sir, we do provide the appreciation certificates.
Sir, that is required.
Yes, sir, yes, sir. Additionally, we provide appreciation certificates, sir.
Yes.
So I see the manuals you have as
Mhm.
SCADA, working with communication.
Yes, correct.
So can you please tell us what you are doing for SCADA?
Actually, the SCADA is like a PC-based system itself. We can able to operate the whole setup of PLCs. By now, you can able to see there are some of the projects that students already developed some kind of example or exercise. So I have told to some of the students like you can think about a steel manufacturing plant, how the steel is coming from the raw material and how it is processing, how you are planning to cut this material, like that I have told you. So simply like that, it has to sense by the sensor. So we have provided some of the switches. If the switches considered by the sensor got sensed in the sense, means it can able to try to operate it. So like this screen itself, I can able to control the whole setup actually. That is what the thing, I can able to monitor as well as give the control of the whole setup of our program. That is what the SCADA refers to our pictures. As it is an HMI base that I am planning to show here, but instead in a PC screen itself, if I want to operate or to be controlled by remote manner or something, then it comes as a SCADA sir actually. That is what
Just
the
to add
PLCs, multiple PLCs.
Yes, sir, correct. Here we are showcasing with only one PLC. If I am operating a whole industry plant with multiple PLC, I can able to get the data. What is the error it is maybe facing, or what kind of a project it has been done. I can able to monitor in the single PC itself the whole data in the single place itself. Sir. That's what we are showcasing here actually.
PLC means what?
Programmable logical controllers actually.
Just to add to what he said, sir, of course, as he said, definitely control is there, monitoring is there, and also data acquisition. So monthly reports, weekly reports related to the plant can be then and there generated with the help of SCADA. So just by sitting in front of one system, we can entirely control the plant, sir. That is quite possible.
That's fine. I didn't ask a question clearly.
Okay.
So when somebody goes for a training with SCADA here, will you connect link them like 2 or 3 PLCs to the
Yes.
supervisor
Yes.
control?
Yes.
Then they will be accessing
Yes.
the data from
Yes.
the PLCs
Correct.
and logging them
Yes.
into the
One
Yeah,
application,
absolutely,
yes.
sir.
that
What
is
we
the
do
training
is-
they will get.
Yes,
And
correct,
that
correct.
communication is through Profinet.
Yes, correct. Profinet only.
So they will they be programming the Profinet?
No, sir, they are not programming the Profinet. With the help of Profinet communication protocol, they are just transferring the data from one
They just
PLC
know
to
that
another.
Profinet exists.
Yes, correct. If they want to make them separately with some other protocol, they can able to perform. Like one way.
Separate electric drive system, you can control.
So the PLC will be connected to the client.
Drive system. Starting.
It's very nice.
Like they have to establish communication.
They will create that setup for training.
This is collaboratively made it actually. Siemens provided the products like the hardware and software to us, and we as the expert will consider about what are the industrial things we are facing and also verification that we have provided this kind of a process. Like we are working
So
in
this is
online for
industrial
500 rupees
sir.
also we will get this.
So we are using for networking. So with all, so now let us say we have this lab, we consider this plant as a lab. So we give this lab only. So we ask them to design the entire lab with the SCADA. So we have 6 kits. These things we do, sir. Yeah, these things we do, sir.
What is the actuator power level that can control using this?
The whole power level is just 4 to 20 milliamperes actually. Here everything is controlled with 4 to 20 milliampere and
Voltage level.
yes, voltage level that 24 voltage DC sir. That's it. Current. Yes.
That is the PLC. So if you want to connect the drive,
Okay.
so that be communication. Okay.
Yes, sir. Yes, sir. So with the Ethernet itself, we can do it, sir. Industrial Ethernet. We have a drive also. We have an AC drive. We do connect. We bring that drive. We connect this PLC and drive. First, we make sure that they both are communicating and control the induction motor through the PLC. Through the PLC. Yeah, through the PLC. It is quite possible.
As I told you, now, sir, this software can able to do with different manufacturer, as I already told you. So similar like that, this PLC can speak up with the other vendor of manufacturer also, and it will create one communication channel. Library files have to be installed in the concerned software place actually. Then, if this 24 voltage or this 4 to 20 milliampere got triggered in this place, this will tell one of the pin, yes, this I got the data. Now I have to run this command, like that it will get it. In such way, we can drive the motors to run in a forward or backward direction up to our requirement actually.
This operation is industry 4.0.
Yes, yes, sir.
But now the industry 2.0 is something is there. If you taken any instruments from industry 2.0.
Actually, as we have told us, as it is an internship related model, first of all, they have to know about the basics of first thing. Depends on the level, we will increase the exposure to the participant actually. Yes. If you want to develop, as I told you, sir, once they given a command in some other lab, some of the operator or some of the actuator will be able to work it out. That is what the 3.0 model. If we can take the whole credit over here, and in the network model, if we can get this feedback and all means, that will come as a 4.0 model in the further cases. That's what that whole internship way we will teach them: automation, mechatronics, then IoT as a part. You can create a server model to us. Then they can elaborately knows that how this industry has been expanded in from past to now. Like that, they can able to explore for sure, sir, actually.
The training you can explain.
Yes, sir.
Sure,
We
sir.
start from the basics, sir. So step by step, one step at a time only, because the students sometimes may be aware of the things, sometimes may not be. So we understand the audience expectation and act accordingly. And with the help of these PLCs, we have some systems, some automatic systems in the ground floor. One is smart factory for sure, and we also have robotics. We have mechatronic systems where the application is clearly visible. That also will show you.
You also mentioned about controlling equipment in another space, right?
Yes, sir.
So from this space or just using PLC?
This PLC will be connected with our intranet, sir, actually, in our college premises. With that intranet, we can able to control other devices actually. If you are make that intranet into the public model, whomsoever create any kind of an app, with that app they can able to control also, sir.
That's the network.
Yes, sir.
Yes.
PLC will be there.
Yes.
In the same network, if the device is there, we can be able to.
So during the COVID season, your lab would have been very popular, I think. Everybody wanted to work on robotics, but you know, at the time you
It was
you just
it was not fully ready, sir.
really I
No,
don't wish
no,
for another pandemic.
no.
Virtual
Making all the
labs.
setups ready.
Yes.
So we are also solving some of the industrial problems also, sir. Recently, Mr. Velumurgan himself, in IISc Bangalore, we had some software installation issue. There we resolved it from here. And then in another one was recently we did where was it?
Same Bangalore.
Bangalore only, no? So such remote work we are doing, sir.
So they are working with like they want to make that start drive is there. So with the start drive, they want to make the communication of this software to be operate over there in a digital twin model like that. So they are planning to do the technomatics is done next to a software. With that software, they want to integrate this setup actually. So we were just given some kind of a knowledge to them. This is how we have to do it like that, and we have just provided some interaction with them actually. Meanwhile, you can tell that some of the students, if they come and watch over the robots for an example, they can know only that there is one pendant will be there. If they operate the pendant, the robot is moving. On the back, the progress, they are working with the PLC in that actually. They are controlling the PLC by coding in their local language actually. That's what we are showcasing them clearly, that how this PLC effectively can be useful if you know in the basic level for them actually. So that's what we are showcasing. Yes. That's what in the video also that we are showcasing, that how the robot can be speaking with another robot in a communication model like that also we are showcasing.
So how many students are coming within the campus, like you are having that nice space?
Yes, yes, sir. students are
Whether they
utilizing,
are
sir.
aware of the.
Yes, sir. Students are aware. For our college students, especially, we are very flexible, sir. We conduct evening batches, evening after their academics, evening 5 o'clock to 7 o'clock, such batches. Weekend batches, only Saturdays and Sundays. Those things are also we are doing for our college students, and especially
you are
during
not having any
summer.
holiday there. So
No, sir. We manage our workload.
Okay.
I mean, let us say if sir is coming at he has an evening batch, he comes late in the
Like-
morning. Yeah, 10 to 7 shift or 11 o'clock to 8 o'clock shift we work. And those who are working in the weekend, immediately the next 2 days they are taken off and take some rest, of course. And summer is a very popular season for us, sir. Last year in summer we received 1,000 applications. So almost for 500 students we have imparted the internship. So this time
College
also.
is doing internships in summer time.
these 2 months are totally back.
Yes, sir. No, May, June, July as well, sir. July as well, fully packed, sir.
Schedule will be
Schedule. But the students providing any account.
Yeah, accommodation is provided, sir. During summer break, here our college students will also be not there, right? So we are providing them accommodation in the campus only.
Like hostels might be given. right?
Yes, sir. Hostels are allowed to them.
PG.
So, I'm a faculty member.
Yes, sir.
I have a question from my professional perspective. So
Yes.
if I know the facilities here, just saying, I just started with this lab, but looking at the manual, it's
Yeah.
amazing. So if I have to design a course for the students,
Okay.
where they can work in groups,
Okay.
some of the course content, but I don't want to mark exams.
Okay.
I'm lazy.
Okay.
So I want to do projects.
Okay. Okay.
So I know it might be expensive sometimes if you have to do for outsiders, but is there a scope, given your bandwidth, to integrate such aspects from an academic perspective?
Yes, sir. Yes, we are doing it, sir. Projects we are guiding, sir. Like our MTech students also, even BTech final year projects also, we are guiding those project works, and in these labs they are doing their project works. Of course, sir, whatever facilities are available are free of cost, sir, at our center. They can utilize our center. Those which are not there, that they will have to bear as a group. But we will guide them, sir. Under our guidance, they can do it.
We can do customized syllabus also, sir, not a problem, sir. As you are requiring
Yeah, that
that
is
customized syllabus.
So for example, like
So,
create a
yes.
lab.
Yeah, but some selected labs. Yes, sir. It is possible, sir.
Depends on the available facilitation that we are having, we can create a customized course for exclusively, and then we can work it out.
It's very interesting.
Currently, our college students are more into projects, sir. From outside, it is difficult for them to come here regularly and work for the project. So the crowd is less from the outside colleges, but our college students are utilizing, sir. MTech, BTech students, scholars also are continuing their research and study in our labs. That opportunity also we are giving to them. On this occasion, I would like to just inform you all, sir. Next month on 21st, right, sir? 21st. 13th, yeah. 13th of March, we are hosting an industry seminar. We are hosting a seminar in Hyderabad, sir. So in a hotel. So we request all of you to join that seminar as well. That is going to be Industry Academia Connect. We are inviting institutes also. We are inviting industries also. So it is going to be a nice place to if you are interested in collaborating with someone from the industries or from our organization or from some other institutes, that's the right place for you all. So now flyers are in progress. Once flyer is ready, I will share it with this, sir. So requesting all of you to join that also. Next month, 13th of March.
One day seminar.
One day seminar, sir.
Location
Timings
is
are
at Secunderabad.
location is
Secunderabad, we are
Secunderabad, sir. 10 o'clock to 1:30, sir. Actual seminar. Post lunch, followed with lunch. Lunch will be there. Post lunch, we can have an interactive session. You all can
What is the
interact.
theme of this?
Sir?
What is the theme of topic?
How this industry and academic curriculum are being in the basis to provide that connectivity over there. Like in one side institute members were there, another side our industry people were there. So how their curriculum will be the part for them to be make that more interaction with them. So that the two beneficial things will be there. So one, they can come to know how this current curriculum will affect their industry, that they can discuss among the speech. Second thing is that they can interact with another people, industry people, so that they can have some rapport with that industry and they can get some placement opportunity for their institution or some people actually.
We have invited a speaker called as Manoj Sona sir. He has his own organization, but he is an employee. He has worked for Siemens as well, sir. So he is going to address what is the expectation of the industry, how industry is working. We also have academic experts, professors like this. So professors will say what are the abilities of the student and what is the role of institute. And we ourselves as Center of Excellence, we say the role of Center of Excellence. So together as institute, industry and Center of Excellence, together we can collaborate and do some good work. That's the motto of this seminar. Once flyer is ready, we will post it. We will tell you some plan accordingly.
Thank you very much.
Most welcome, sir. Shall we go to the electrical lab, sir? Please.
They have to do the hands-on practice on it. Okay, sir. And we also have a 3RW 44 model soft starter, which is used to run the motors without any vibrations and spikes. Okay, sir. And we also have a 3RW 44 is the advanced level soft starter, sir, which have a different types of function. While we are commissioning through the motors to the soft starter, we have to put the different types of functions. Like suppose if I'm on the soft starter with what the specifications in the motor, we have to commission it through the soft starter. But I have selected the impulse function. Impulse function means nobody will if you touch means automatically the contract will off condition. But it is off for the 5 to 10 seconds only, and after that it will be on. Okay, if the operator will long press for 2 seconds, then it will be off condition. Okay, like that we have some functions in the 3RW44, sir, and we also have this is used for the higher applications, and we also have a low voltage applications. We have this is also one type of soft starter, 3RW30 model, sir, this one, and this is the 44 model, which is designed from the Siemens. Okay, sir, and we also have 8 circuit breakers, which is used up to the breaking capacity 55 kiloamperes, and the trainees who are coming for the batches, they have to tell about that how to maintain these circuit breakers and how to rack out and rack in process, and how to use the ETU functions to trip the circuit, and how to charge this circuit in the off condition, and how to charge the air in this circuit breaker to break the contacts. And we also tell about this shunt coil and UV coil, under voltage coil and shunt coil, how they have to operate while the fault occurs. Okay, sir. And we also have 2 types of chargings. One is mechanically loaded charging and one is the electrically loaded. If the transformer is fitted above the transformers, if the air circuit breaker is fitted above the transformer, means the operator won't be operate like this to mechanically loaded this spring loaded. So for that purpose we are using the electrically loading, and if the air circuit breaker is fitted below the any control panels or any near to the transformer, means they have to operate like, and we have to this is the discharge condition, the air will be discharged. Now I have to charge this circuit breaker with 7 times the spring, it will be loaded to the motor operated control. Okay, then it will be operated to on and off condition. Okay, in back side we have a arc fencing, sir. In this arc fencing, whenever the fault current, automatically it comes from the arc. And this is the one type of Siemens brand, sir, 3WL, and that other side is 3WT, and same specifications is specification is equal only, but that is used for the robust conditions, and this is used for the not used for the outdoor installations. Current rating is up to 55 kiloamperes, sir. And we also have a energy saving. And we also have a last finally they have to students they have to know how to energy saving in terms of drives. And we also in this we have a 3 types of feeders, sir. One is DVL mode and direct online mode, which I have also seen below 5 HP motors, and we have a soft starter mode. In the soft starter mode, how the motors have the applications are using in the industries and paper industries and oil and gas industries like that. And how we have a drive, how to change the motors, why we are most important present in the using the drives. And from this we have to show in terms of current only. In DVL mode, it takes the high current that is starting 25 to it's set it to 4 amperes. And they have to know how the direct online mode operation, the current is high starting current while initial condition. Okay. And next in for the soft starter mode, and it is also it runs in same condition only, but it will be the motor we have to run with without any vibrations and spikes. And in the drive option, we have a forward condition. They have to we have an option as forward, and we have to select the speed also. How much speed also suddenly you have to like in our locomotive Vande Bharat trains like that, and how to operate like in drive operation. You have to go. Okay. And from that we also tell about the separately from the students to how to design the drives.
So whether it is a VFD or some other.
VFD only, sir. Voltage frequency drives only. But for the Siemens product, we have calling as G120 AC, which is and we also have how to operate, how to commissioning the IOPs, intelligent operating panels, and how to fit it and how to commissioning this power unit and control unit and this IOPs. In industries, the engineers won't use this IOPs to the operators, technician, because all the program is included in this IOPs. They simply they have to connect this, and they have to commission this type of motors to this IOPs. From the IOPs, commissioning the AC drive to the motor, and second task is how to commissioning this drive to the software. We have a start software, sir. That is one of the commissioning tool to use the commissioning the motors to the drives. This is the AC drive, same like the DC drive also. Same like that we have also have a commissioning to the basic operating panel, and commissioning to the starter software. How to commissioning starter software, and how to give the different types of functions like step up functions and ramp up functions, job functions. And we also have a starter unit, sir. This is the classical starter unit. Before the 90s, they are using this much type of campaign size of starter, but nowadays innovative innovations.
Contact.
These are all the contactors, three contactors, star, delta. And from the contactors, they have to connect like this, and from this, they have to operate the motor. Actually, they given a previous induction motor. For students, they have to connect this circuit to the motor, and they have to operate.
One of the application of PLC is this one, sir. As you can see, through our HMI, human machine interface, we are able to, via PLC, we are able to control these 3 feeders. One is DOL as sir said, traditional method. One is using soft starter, the other is using smartly with the drive. So one of the applications is for the PLC is energy saving device.
We also have a MCB molded case circuit breaker, which is equal to the KCB A circuit breaker, and we also have a motor operator, and which have to lock this MCB also. This is the motor operator, and how to we have to fit this answer to the MC series. We have 2 types of MC series. This is TVM and series TVA. TVM is used for the low voltage applications, just off and on. And for TVA it is used for the higher application. They have to set this overall current, short circuit current, and and if you give this MCCB is connected to the control circuit, the control station, they have to connect this motor operator. From the motor operator, they have to operate the overview of this class.
Thank you so much.
Same set, sir. Total 5 kids.
And welcome to Test and Optimization Lab. Welcome, sir, and also our distinguished faculty, Salom Kumar sir, Amar Salom sir, and Professor Giridhar sir. So this lab is also part of mechanical engineering PLM cycle, which involves multiple domains falling under CAE, Computer Aided Engineering, which is one of the pillars in CAD, CAM and CAE, like you know. So in this lab, basically we have divided this lab into two parts. It can be divided into multiple parts, but to broadly classify, we can say it has study of vibrations, and the another part is study of simulations, which is finite element analysis. We have developed finite element analysis in recent years so much to a level that now computers are able to definitely perform simulations without practically going for any experiments or testing methods. So this definitely is one of the non-invasive method in which you can determine the problems associated with either a design of part, machine, or it can be even a predictive maintenance approach to determine whether there are faults or problems associated with machines. So as a part of these experiments and as a part of industrial experience for students, we have arranged several setups over here. One of them is our setup for determining the natural frequencies of objects. So this is a general term, but specifically speaking for this experiment, what we have here is scaled down model of an aeroplane. So basically in the aerospace industry or even in automotive industry, what they perform is modal analysis. So nowadays we have definitely determined that modal analysis are very much important to determine the natural frequencies of object, because while in operation they should not achieve the resonance, which is highly damaging to the structure. So in order to avoid that resonance, we must determine the natural frequencies as close as possible to the actual structure as well. So this is just a scaled down model, and we have also performed the same experiment in SimCenter 3D also. So our first product is SimCenter 3D, which is nothing but a multi-physics software for solid mechanics analysis in solid mechanics using FEM methods. So in that software you are able to perform multi-physics analysis like one that is shown over here, which involves study of aerodynamics as well as structural. So it can involve both. It can have standalone simulation as well based on FES, like finite element analysis, which is again based on finite element method. So it involves both practical syllabus of students which they are learning like solid mechanics as well as numerical methods, as well as principles of failures, machine design.
which are combined together in this topic, where they will finally get to engineer better products using all these studies. So this is one of the example. Another example what we have here is electric motors. So as we know, induction motors are very much common in industries today. Also they are like heavily employed with various sizes as well. So this can be also similar to what engineering has been employed in larger ships or larger engines as well. So this can be similar to that as well. So basically what we have here is a VFD coupled with electric motor, and it has some load attached to it that can be balanced and unbalanced using these bolts that can be removed. And we also have a coupler with bearings attached to it. Okay, so basically what we can do here is find out the problems that are associated with electric motors without any invasive methods. So it is one of the non-invasive methods where we can find out using vibration analysis. So what we can do here is we have multiple transducers. So this is accelerometer. And we do have a data acquisition system that is provided by Siemens itself. So this data acquisition system is nothing but capturing the data in from sensors, which is in analog form, converting into digital forms, and providing interface to interact with our systems, PC systems. So it has also additional capabilities of post-processing as well, which is integrated with software. So our next product is Test Lab. Test Lab is a software where you can integrate it with data acquisition system easily. It's already integrated, so that you can capture the data according to your specifications within, for example, if it's data on vibrations and you have to capture in frequency domain, so you can properly set up the experiment by setting up the frequency domain or sampling frequency, or you can say when should trigger start or triggered stop, when it should start or when it should stop. So conditions like that can be easily set using this and as well as software. So Test Lab is another great software that is used in aerospace, research, defense, DRDO industry, and even automotive industries are mostly using it. So it does have that CAN analyzer interface as well as communication whole board is there with different ports attached to it to interact with different devices. So definitely it has some protocols to follow as specified by the Siemens. So this is one of the important instruments that will be used in frequency or vibration analysis. So these two experiments, and also we have one more setup, which is a vacuum cleaner. So that can be coupled with this transducer, which is free field microphone. So it's similar to study of vibrations. Basically both are based on pressure measurement. So that's why we have been given this one more experiment to determine the sound intensity or sound pressure levels based on these sensors as well. And this is also integrated with our SCADAs and also Test Lab software.
How does this sensor work?
So it's same as our human hearing range, and it can capture the frequencies based on the same principle of vibrating piezoelectric. Yes, it is connected to DAQ using the coaxial cables, which are BLC connectors. So audio and visual signals can be captured very properly without any disturbances.
For our group, this is very relevant for workshop. Is there any way we can see it online?
Definitely we can perform it here as well. Yes, sure. So should we start with this?
Yeah, please.
but you run it in the general course. So in that way, especially even though we give the scale down models, but the thing is that we try to validate everything strict. So it's like you have a model and analysis software with you, and if at all you want to model, and then you can design your experiment based on whatever the input and then analysis whatever you make. And even especially the SCADA and the sensors along with the test lab software, it gives a lot of ways to think with respect to model your own experiments. So this is what we give it to show that yes, how these equipments can be used. So based on that, many MTech peoples and BTech students for their project, and then even PhD students also, especially Srikanth's student who was in PDB lab. So they perform some experiments for their research work based on whatever they learned, and by understanding what are the capabilities of whatever the equipments and software we have. So based on that, they used it and then they were using it. So we are very much happy that yes, this is not just a lab similar to what we have in the curriculum lab. It's much more than that. So in that way, we are very much happy. All credit goes to Dinesh, who really does in a way that yes, like it gives the insight that where it can be taken. For example, so it's not that this experiment means it's not done there itself. So what are the applications, what are the scopes for you to use these experiments and use these equipment and then this facility. So in that way, I really like to thank Dinesh for that.
Credit also goes to Selvam sir.
No.
Because sir is the faculty in charge for this lab along with Prashant sir, and framing the syllabus, and somewhere if we are stuck, then definitely sir helps us.
Yes. So this is connecting to PC is just Ethernet cable, or we can say RJ45 cable. Along with that, now I will also connect. So this is a test lab software, and these are the different modules. I know you cannot read, but I will read out for you. So first one is 3D acoustic camera, second one is exterior pass by noise testing, and one more is sound diagnosis, sound intensity testing, transfer path analysis. Like that, Siemens has developed a wide range of applications for their products. So they have applications in NVH based on whatever the vibrations or studies you have. They have multiple approaches for that. So one of these is also there, but now we will start with application of these two electric motors. So in test lab signature acquisition, basically this module is divided into signature acquisition. So why it is divided into signature acquisition? It's very basic. So like each machine has its own natural vibration, or we can say frequency of vibration which it will vibrate at its own natural frequency. So like a person has his own signature, definitely each machine will have its own frequency. So that's why it's called as signature acquisition. And we are going to acquire the vibrations it will produce when it's perfectly balanced. we will do next is we will create an imbalance. So I think as you can see here, there are multiple problems associated with rotary motors, or you can say even rotor dynamics. When we are studying, there are multiple problems discussed. So a couple of them are written over here, like mass imbalance or misalignment or shaft bow or bearing wear, or you can even see cracked rotor, looseness. So all these are further analyzed by deep study, because many times you will see whenever you get the output, which we will see from it here now, is a combined output of all the frequencies. So how can we separate those output? How can we use fast Fourier transform or fast Fourier transform or other mathematical tools to extract the frequencies from that graphs or the studies what we have conducted? So we will study one such problem from this, which is imbalance of mass, or you can say loads connected to it. So I'll just open one module which is called as signature acquisition. So first I will capture it on the balance state, and then we can capture it on the imbalance state as well. No, I am about the connect system. So this accelerometer will be capturing the vibrations, and it has its own coaxial cable with one input cable for the SCADAs. Sorry, I mixed it. This is the input cable for the sensor, and these are the 3 axes for the SCADAs. So there are some guidelines when in industry. You definitely have to check whether your base setup is properly fixed to the ground. Is there any looseness attached to it before you are commissioning the machine? Also, you have to ensure that whenever you use the sensor, there are some guidelines in the industry. When you are using on electric motor, you are most probably used to try to use it wherever you have a flat surface where the, or you can say rigid body has been transferring the vibrations, because if it's not a rigid body, it will not properly transfer all the vibrations. So make sure that if it's a rigid body, like there is a connection over here, so we can assume that whatever the vibrations produced here are here as well. Okay, so we'll connect for example here, and we do have 3 axes written on it, X, Y and Z. So make sure you know about the axis, because while interpreting the graphs, we must know which axis is producing the maximum vibrations, because it is of interest for us. So this is nothing but these are BNC connectors which carry the excellent audio and video signals. Just for the interface connection, we have another cable from BNC to this communication cable. So it may change from data acquisition system to the data acquisition system. So there are 3 cards I can say on this data acquisition system. So this is a communication card which I have connected to the PC. This is data acquisition from sensors. 8 ports are there, and this is the power. So we can even power it using different methods are there. So I'll connect it to number 1, 2 and 3. And in software I have already started one data acquisition, so I will open a sample file. So usually what happens is when you don't have connected systems like this, what you do is you can prepare your own data acquisition system, which can be prepared using IoT devices or ESP controllers or even some other Raspberry Pi devices, which are just for the purpose of project or presentation. But while in commercial, these systems are definitely used there. So it's similar to that as well, but there we have to create your own code as well to acquire the data and then also transfer the data to your own system. So this software has also some great features, which is like these are the worksheets. These are called as worksheets. Basically, if you know that whatever you are performing is within the defined recipe of the software, you can select that and follow the worksheets as well. So here there is nothing but this tab until here is for setup. So whatever the setup you are doing must be known by the operator, because you have to look for values or look for commands whatever you are giving within a certain range. It cannot be randomly considered. For example, if you are saying for some frequency, you must look within the range. But otherwise, there are many other errors that can happen, like quantization error, aliasing error, or leakage. So for that purpose, a few setup worksheets are given over here. Next is measurement. So until here, 3-4 worksheets are for measurement. So during measurement, what exactly you want to capture? Whether you want to capture the raw data, which is its original form, or you want to process the data there itself. It has that capability to process the data as well. Because it's advanced, it has those capabilities as well. So
processing will happen in this box?
yes, it will process here as well and in software as well. So both capabilities are there. So it can capture the data with the help of this box as well. So we can specify, let's say we want to measure certain range as well with the help of that accelerometer. So it will send commands to that accelerometer if it's out of range. It will show as overloaded if the signal is too strong. So basically,
this is having that storage facilities inside this box, otherwise you have to store it in
I think as far as I know, it has analog to digital converter with microcontroller and processing unit. Storage might be there, but definitely it is a live instrument which is transferring it to PC. So I think little bit storage will be there just for RAM memory, I think, not for so I think because we have the storage over there, it can be considered.
Just to add, this SCADA is different from the one which you discussed in the automation lab.
So this SCADA name is full form is signal conditioning (SC) and data acquisition system (DAC). So this is different than the other SCADAs in automation. And here a few more tabs are given for post processing. Like we want to process the signal. Let's say we want mean, median, or kurtosis, or any other factor which we want to acquire from that signal. So basically, as we know, we can capture the vibration signals in two forms, that is time domain and frequency domain. So we will go for for the next worksheet. This is a documentation worksheet basically. This here you can write your own notes, add your own images, documents, because you're in industry you need to specify who has specified that project, what is the name of the assignee or who is conducting that. So that's why these official things are given in this page. Next is navigator worksheet, where you have 3 sections. So the first section is data viewing, second one can be said as data presentation, and third one is data calculator as well. So this is data viewing, okay, and to present the data, basically we can right click here and see multiple multiple options are there. If you want to export it into Word format, or you can say even a PPT format, it can be done from here. For this our experiment, what we will do is, this is basically from my computer you can select the link. So I will select my own data from here. I don't have geometry for that because we only have one sensor and we need to determine the signature frequency of that. So geometry will not be needed. Now here in channel setup, this is about the channels which we have connected for that. So for this sensor we have connected 3 channels like X, Y and Z of the sensor. So if I turn it off, you can see those channels will also turn off. So right now the 4th channel will be on and the first 3 are turned off. Charging. So I need to reconnect it, just give me 1 moment. So in the meantime, I will also attach a laser sensor which can be used to determine the rotation speed of the object, or you can say basically induction motor, which will also have. So this is the same DNC connector cable, and there is one retroreflective tape where the laser beam will bounce back from this, and you can determine how fast it is running. first 3 channels. So I think now there will be the green lights will be lit on the first 3. So they are showing some error is there in the sensor. So we'll check that as well. Just 1 minute, give me 1 minute. There is a little grounding problem because it's a European model. They have given only 2 pin plugs. It's fine, I will try. Okay, now I think it's okay now. So there might be an issue with connection as well. So once I set this and I confirm that all 3 inputs are good, okay, good to go, I can set the axis which is x, y, z written over here. Next we can set the quantity that we want to measure. So here it's measured as acceleration. So vibrations can be measured in 3 forms: acceleration, velocity and displacement. And we can set the values of calibration which are nominal sensitivities. So there are actual sensitivities and nominal sensitivities which can be set according to the documentation provided by the calibration or even the provider manufacturer itself. So once we set that and we set the axis, we can go for the next worksheet. Since we don't have a calibrator over here, we will skip that. We will use the nominal sensitivities. And for tracking setup, we will use the time guided tracking. So it is from 300 rpm to 1200. As soon as it hits 300 rpm, it will start measurement. And once it crosses 1200 rpm, it will stop measurement. So that's why the laser tachometer is also integrated with that. And we also have a triggered start. So beyond that, which is like 300 rpm, it will start measurement. So other settings are also there. Basically, what will be the bandwidth, sampling frequency, that can be also set here. So set this mode as well. So you can see there is one laser beam pointing. So I think this value is coming almost right, because every time I get same value of 1492. So definitely we are getting a similar value. Just because of some reflections there might be a little bit of variation. So this is nothing but a trigger value point which we can definitely change. So when there is a signal that we see is appearing within this range, we can set the trigger value as well. After that, we can, this is only for tachometer. So once we have a proper signal, we can see the value is written over here in RPM. We can even derive our own formula as well, which can be added into software. For example, let's say this was engine, where you will have like a ship engine, big engine, where you will have converted your revolutions per minute into velocity of the vehicle. So you can multiply it by that formula, pi r square 2 pi r, supplied here in the formula, and then you can even display your own units as well, whichever you want to convert it into. Next one will be acquisition setup. So this is the main part where we will start with acquisition, data acquisition. Now as you can see, I have set the acquisition parameters, in which the first one will be the frequency, bandwidth. So we can say bandwidth will be the time span in which we want to capture between this frequency and this frequency. Next will be the resolution we want. So I will keep according to the law as 2.5 times. Frequency lines we can set just to calculate the resolution, which is automatically calculated. Once we have 2, 3 values, the other things will be automatically calculated with the help of formulas. And this is the time domain I would like to show you. So limits I will set it as free. And if I switch it to frequency domain, you can see there are a couple of frequencies that are giving peak outputs. So for example, so you can see here there is one peak appearing over here. So and one peak appearing over here, one peak appearing over here. So these may be the orders in which they will appear. So they may be repeated as well. But if we are interested in the first orders where you will find the natural frequencies, we can focus on the first few parts. Because there will be tools to determine the natural frequencies in that range. Okay. Once we confirm the range, then we can proceed for the accurate testing, physical testing as well. For example, if I want to focus on this area as well, I can zoom in on this area and see whatever the frequency will be there. So if I put a marker over here, I can see the exact value. So this is showing 324 Hz. There is one peak I can see. So I can even start the ranging of accelerometer. As you can see here, the units are within millimeter per second square. That is measurement of acceleration. This is the amplitude level, and this is in hertz as we are working in frequency domain. If it was in time domain, it would be in seconds. Amplitude versus seconds. So we can see that the maximum range that is going until 30 millimeter per second square. So it has already, I have started the ranging and it has already measured that. So let me see if I tap it more. You can see it has exceeded the limit as well. So based on your calibration, it will properly set the range. And the purpose of giving this range is we should always measure the data within some proper ranges so that we can avoid the errors, cumulative errors that we are going to capture. So I will again stop, start the ranging as well. So now we can see it's reaching until 22.59 millimeter per second square. Now we will set the range and proceed to the next tab, which is online processing. Now this is nothing but this is where you will set what you want to capture. So there are multiple things, order sections, frequency sections, or octave sections, which is again in the form of vibrations, but it's captured from half-inch microphones or audio signals. So if you want to capture that, because octaves are the measurements in, as you know, in acoustics. So apart from that, overall level map statistic is there where you can calculate spectrum values or any other energy values through the spectrum you want to calculate. Those are also there. We will keep the default settings for now and go to measurement. So this is the measure panel tab where we are acquiring the data. Once I click arm the signal, arm the sensor, it is ready for capturing the measurement. So I will reduce, as I have set it to capture the signal from 300 to 1200 RPM. I will reduce it and start it slowly. So now that it's ready, you can increase it slowly. I have started the measurement. Just hold on. It's overloaded. Just 1 moment. So as it is showing overloaded, I am looking for another sensor. Just give me 1 moment. Is there another sensor? Yeah. Okay, sorry for the interruption. So we will start the experiment. So we'll resume the experiment again, and temporarily I put it on table, but definitely you should put it on structure. Right now we are, I don't know, having grounding, little bit grounding problem suddenly. So so I might have to set up it again. Just give me one moment.
They're very fast with that. They're very rapidly. They're very fast with that. So these things, it's delicate, you need to be very slow with that.
started on 300 again. This is the run-up measurement. So it was stopped on 1200. So now we will save this data and further plot this. So I will disarm it now and I will show you one plot of it. So here you can see the first run was very short, second run what we will have the throughput data, and there is a whole lot of visualization plots which we can create based on whatever the requirements you have. So for example, we will have this waterfall plot which is useful to see all three sections, that is time domain, frequency domain and amplitude as well. So if I put the raw signal of Y, so these are the frequencies that are captured at different RPMs, and if I put it here you can see there is one plot created. So if I zoom in a little bit, you can see there is one peak that is appearing over here in this range. So if I put one single cursor in X direction and move it over here, I can see that there is 17 Hz frequency that is popping up here. And next one is 100 Hz that is shown over here. These are automatically right now put here, but we can make close observations and then we can find out the frequencies that are shown over here. Now if I create an imbalance over there, definitely there will be another frequency that will be showing up. Let's try it out. So it might be resonating with the vibration of some of the parts here. So we can again, once we have the imbalance, we can same way, now let's say we had the data for perfect machinery or when it's properly aligned, and once we have that, We can always maintain a routine checkup where like 1 week or 2 weeks, 3 weeks, where we monitor the data of the machinery. In that way, we can even make a maintenance program or determine the health of the machine. Put it until 25 hours. So it does ask us if data is overloaded, do you want to keep it, how do you want to process it. We can go ahead and process the data. So we can put another plot besides it and we can check, like it was in run 3. So we have the throughput data and so as y-axis is of interest, I will just plot the y-axis data. You can see the amplitude is definitely increased in this. Before it was very low. You will just see the values. Just give me one moment. So the amplitude is until 1986. We can say millimeter per second square. Definitely a considerable value than the previous one. So this same thing can be experienced in multiple setups as well, where you have rotating machineries. So right now we only have one frequency that is showing up until 13 Hz, which is of different than the 17 Hz. So if we are able to match that 17 Hz of the machine as well, it will definitely display a resonance where whole setup will vibrate, and I have seen that in multiple cases also. Sometimes I have even seen when I match the frequency of the table itself vibrating, the whole floor will be also vibrating with itself as well. So this is one of the methods where you can use like non-invasive techniques for determining this. And right now it's being developed by many other companies as well. They are directly marketing their products like analyzer itself, so that you can directly plug your accelerometer and measure the acceleration vibrations in the industry or the machinery where you want to employ this technique as well. So this is the experiment that you can utilize it for multiple analysis as well. So the same another experiment is what we can say about the modal analysis. It's also based on the same principles of vibration. So
Same thing we can adopt for vehicle also.
yes. On
You can keep all these sensors and you can check the
on study of engines, rotating machineries, the whole rotating machinery domains come into this picture.
So, accelerometer from Siemens or from other vendor?
No, it is from another vendor called
Cost of the
DC.
accelerometer?
Huh?
Accelerometer, what is the cost of this accelerometer?
It might be around, I still don't have idea, but 2-3
Very costly.
The accuracy will be high.
Yes, yes.
might be, I don't know exactly.
It's too. Thank you so
A
much.
round
sir,
of
for-
applause to Dinesh sir.
I know you probably have planned something else for us. And